In the previous movie, we finished rigging our character's left hand. In this movie, we'll look at how to mirror our character's left appendages to our right side. Start by opening the file Character Rigging, Part 32 Start, or by using your own file from the previous lesson. If you spent any time modeling, your first thought may be to duplicate the left side of the rig to the right side and invert its scale. Let's first try it on the leg. Select the left leg group and go to the Edit, Duplicate Special options. Reset the settings, then set Scale X to -1 and click Duplicate Special. The leg duplicate appears to be mirrored correctly, so let's try posing it using the FK controls. Although all the joints have been duplicated, the FK leg no longer drives the result leg. The same goes for the IK controls, which we'll have trouble checking since the left leg settings control hasn't been mirrored either. This happens because we didn't duplicate the input connections along with the joints, which cut any connectivity between them, such as the FK-IK blending mode, the no-flip pole vector knee, and the joint scaling. So if we could just duplicate those connections along with the joints, then mirror them, that should be sufficient for the right side, right? Let's try it. Undo the duplication, then select the EMMA root transform control. Open the Duplicate Special options window. There are two options here regarding connections: Duplicate Input Graph and Duplicate Input Connections. Duplicate Input Graph will duplicate anything and everything connected to the selected objects in the scene, including blend color nodes, multiply divide nodes, clamp nodes, and so on. Duplicate Input Connections won't duplicate anything you haven't selected. Instead, it will duplicate only the connections to existing nodes. So if we duplicated the left leg using the latter option, we'd end up with the right leg being tied to the left leg's IK-FK blend, squash and stretch calculations, and so on. Obviously, we don't want that, so we'll use the Duplicate Input Graph option instead. Maya duplicates the entire rig. We don't need the duplicated head, neck, or torso rigs, or their related locators or controls, so delete them. Reparent the remaining groups to the EMMA root transform control. Delete the duplicate root transform. Now set the shoulder, arm, hand, and leg duplicated groups Scale X attribute to -1. An initial inspection seems promising. The right result leg is slightly off from the FK control as a result of the space locators we removed, but that would be easily fixable. More importantly, the controls themselves seem to be intact and working. Notice that rotating corresponding left and right FK joints results in mirrored rotations. This is also correct, as it gives the animator consistent control over the joint's rotations. This rule also applies to mirrored translation-based only controls, notably the shoulder controls. However, this is not true of the arm or foot controls. For example, switch the legs to IK mode and move both feet in the X-axis. Notice how they move away from each other? Unfortunately, this is a big problem. Both leg controls should move in the same direction because, contrary to mirrored FK controls and translation-only controls, we don't want mirrored world space IK controls to be inversed. Think about what would happen if the animator moved the character's body and legs in the X-axis at the same time. The body and left leg's position would go one way, while the right leg would go another. This is symptomatic of a larger problem, which is that the controls and joints exist in mirrored spaces. We can't fix this by freezing the mirrored controls transforms either, because it would impact all the connected nodes that drive things like joint scale. So what does this all mean? Unfortunately, it means there's no easy way out, and we actually have to recreate the right leg and right arm rigs. It's the only way to guarantee everything will act predictably in the space we want. Before you pull up your sleeves once again, we have some handy tips and tricks you can use to make the process less painful than the first go-around. First, we can actually use mirrored geometry, since we don't need to rotate or translate them directly. This will save you from having to slice up the new leg, arm, and hand. Select all the left appendage geometry. Open the Duplicate Special window and reset the settings. Set Group Under to World. Let's rename all the references to left to right. Next, group all the duplicate geometry together and set the group's scale x value to -1. Note that we have to unlock the attributes of the palm geometry because the original was skinned to the left hand. Next, we'll use the mirror joint command to mirror our existing left joints to the right side. Select the left thigh result joint and go to the skeleton mirror joint options. We can use this window to mirror joints across an axis plane, in this case the YZ axis. The mirror function affects the resulting mirror joint's orientation. Behavior will create a joint chain whose rotation away from the mirror axis will be inversed, whereas orientation will create a joint chain where the rotation will be the same as if it was created by default in that position. In this case, we're going to use behavior in order to get consistent rotations across the mirrored joints. Finally, we'll rename all objects by replacing the left identifiers with right. Maya creates a mirrored leg. If you compared its local rotation axes to that of the left leg, you'd notice that the x-axes run in opposite directions. You'll also notice Maya has attempted to mirror the geometry as well, since it is a child of our result joints. However, because of the orientation of the leg versus the geometry, the results aren't quite right. Delete this extra geometry. The new joint orientations facilitate the mirrored rotations we want without inversing the scale. Now parent the mirrored leg geometry from before to the appropriate parts of the leg. Reparent the joint chain under the Emma-Root transform control, and then group it into a right leg group. Mirror the left FK and IK leg the same way. Note that to do so, you'll have to unlock their transform attributes, otherwise Maya won't be able to mirror them correctly. The curves won't be oriented properly anymore due to the differing local rotation axes, so you'll have to move and rotate their control vertices to line up with the left leg controls. From here, you'll have to recreate the FK and IK legs functionality, then use the same principles to recreate the right arm as well. Consider this a good chance to review the lessons you learned in Part 12 to 27. However, to save you time and give you a basis for comparison, we've also included a fully mirrored scene file linked below. Looking at the near completed rig, there are a few things to note. First, due to the change in local rotation axes for most of the right side joints, their translation values are actually negative. This is an important distinction to recognize when implementing anything involving measurement nodes. You'll need to invert distance values by multiplying them by -1 to make them usable. Also notice, if we select both IK foot controls and modify the various attributes, some react inversely to each other. We accomplish this by adding a multiply-divide node between the connections from the foot control to their respective controlling nodes, then multiplying their values by -1. This type of mirrored attribute relationship is a common convention for most animators. And of course, as we mentioned earlier, the foot controls now exist in the same space. Moving to the arm, notice that although the arm result, FK, and IK joints all follow the same local rotation axes, the segmented arm joints do not. This is to ensure the twist works correctly, and is okay because we will never interact with these joints directly. Finally, the hand and shoulder present an interesting case. Because of the nature of the hand manipulation, and because the shoulder's translation-based controls actually do require an inverse relationship to its left counterpart, we can use a mirror-duplicated version of both these body parts. Being able to make a decision like this is one of the advantages of building a rig piece by piece instead of as a one skeleton. Start by deleting the existing right shoulder and hand geometry. Next, select the left hand group and open the Duplicate Special window. Reset the settings, then turn on Duplicate Input Graph. You'll notice this actually duplicates our entire rig, since the hand is attached to the rest of the rig via the DG. Reparent the duplicated shoulder and hand groups to the Emma root transform control. We'll also copy over the arm space locators. Point snapping them to the right shoulder end result joint. Delete the rest of the duplicated rig. Now set scale X on each of these groups to -1 to mirror them on the other side. Notice all individual controls are still intact and working. Select both duplicated groups and rename all the objects by replacing the left identifiers with right. And make sure to reparent the right arm body space loc to the torso's Do Not Touch group. However, in addition to the nodes under the right shoulder group and right hand group, we need to rename all the multiply divide nodes and animation curves we created for these controls as well. Turn off DAG objects only in the outliner. If you look at the animation curves, notice all these duplicates. Select all the ones pertaining to the duplicate shoulder, hand, or fingers. Repeat this for the multiply divide nodes. Rename them all from left to right. Now to make sure we didn't create any extra duplicates in this process that may clutter up our scene, go to File, Optimize Scene Size Options. Beside rendering nodes, click Optimize Now. This will remove any rendering nodes, which includes all utility nodes, such as multiply divide, that aren't attached to anything. Finally, we just need to set up the appropriate constraints so these mirrored limbs work in tandem with the torso. We can set up the shoulder exactly as we did on the left side by parent constraining it to the shoulder bind joint. However, when we try constraining the right hand const group to the right hand result joint, or the right arm base IK const group to the right arm space locators, notice it causes a 180-degree flip. This is due to the non-matching spaces. In this case, the hand group exists in a mirrored space, while the arm joints do not. To rectify this, delete the parent constraint and pre-rotate the right hand const group, then set a new parent constraint. You'll need to do the same when parent constraining the right arm N bind joint to the right hand base const joint. This finishes our entire rig. Although there are many variations on the standard bipedal character rig, what we've shown you in these lessons forms a strong foundation on which you can append new rig functionalities. Once you're ready, you can hide all the proxy geometry from this rig and skin the result joints to your final mesh to create a skinned character. However, before you do that, you may want to consider an additional bit of functionality. Although our blend nodes allow us to easily blend from an IK appendage position to an FK one and vice versa, it would be really nice if we could snap one to the other. This would allow us to switch seamlessly from one mode to another in mid-animation without any undesirable pops. In our first appendix series, we'll build a script that adds this IK-FK joint snapping to our rig.